हे एवरीवन, वेलकम बैक टू पीटीएस कैड एक्सपर्ट। आज की वीडियो के अंदर हम पूरा डिटेल में देखने वाले हैं कि पैरामेट्रिक मॉडलिंग स्पेशली डोर और विंडो का क्रिएशन रेविट आर्किटेक्चर के अंदर आप कैसे कर सकते हैं। अगर आप सिंपल आर्किटेक्चर वर्क कर रहे हैं रेविट के अंदर तो आप जो स्टैंडर्ड लाइब्रेरी है उसके डोर और विंडो यूज कर सकते हैं। लेकिन अगर आप बीआईएम वर्क कर रहे हैं तो आपको कस्टमर के रिक्वायरमेंट के अकॉर्डिंग या प्रोजेक्ट के डिमांड के अकॉर्डिंग जो भी डोर और विंडो के स्टाइल होते हैं वो आपको कस्टमाइज करने पड़ते हैं, नए तरीके से बनाने पड़ते हैं। और उसमें भी एक कंस्ट्रेंट होता है कि जब आपको उसके साइज में वेरिएबिलिटी करनी हो तो आप स्केचअप या 3ds मैक्स की तरह डायरेक्ट स्केल नहीं कर सकते। उसके लिए आपको प्रॉपर उसमें साइज डिफाइन करना होता है। तो उसे डिफाइन करने के लिए हम पैरामेट्रिक मॉडलिंग का यूज करते हैं, फैमिलीज का यूज करते हैं। और स्पेशली फैमिलीज के अंदर हम कैसे कंस्ट्रेंट्स का यूज करते हैं, कैसे रेफरेंसेस का यूज करते हैं, उनका यूज करके किस तरह से डायमेंशंस डिफाइन करते हैं, डायमेंशंस को लॉक करते हैं और फ्यूचर में जब भी हमें साइज चेंज करना हो तो हम इजीली वो साइज चेंज कर पाएं। तो ये सारा प्रोसेस बहुत इंपॉर्टेंट है। अगर आप रेविट के अंदर एक्सपर्टाइज गेन करना चाहते हैं तो पैरामेट्रिक मॉडलिंग आपको जरूर आनी चाहिए। तो इस 2 घंटे की वीडियो में हम स्टेप बाय स्टेप देखने वाले हैं कि किस तरीके से जब आप नए स्टाइल के डोर बनाते हैं, डबल पैनल में बनाते हैं, सिंगल पैनल में बनाते हैं, कंबाइंड डोर के साथ विंडो कंबाइंड जो फ्लैट के अंदर आप देखते हैं उस तरह के अगर आप डिजाइन्स बना रहे हैं तो कैसे रेविट के अंदर आप वो सारी चीजें कर पाएंगे और किस तरीके से वो प्रॉपर डायमेंशंस आप डिफाइन कर पाएंगे। तो ये वीडियो देखने के बाद डेफिनेटली आपको पैरामेट्रिक मॉडलिंग में स्पेशली डोर और विंडो डिजाइन में कहीं कोई डाउट नहीं रहेगा और बहुत डिटेल में एक एक चीज कुमार कपाड़िया सर ने इस वीडियो के अंदर डिटेल में आपको समझाई है। पर ये वीडियो इंग्लिश में है तो मेक श्योर आप इसे कनेक्ट करें और जो इसके कैप्शंस हैं उसे ऑन कर लीजिए अगर आप हिंदी में देखना चाहते हैं। एंड वन मोर थिंग, अगर आप ये लाइब्रेरी डाउनलोड करना चाहते हैं तो इस वीडियो के डिस्क्रिप्शन में जाकर के जो डोर और विंडो के स्टैंडर्ड लाइब्रेरी हमने यूज किए हैं उनको आप डाउनलोड भी कर सकते हैं। सो आई होप इस वीडियो से आपको बहुत कुछ सीखने को मिले। अगर ये वीडियो आपको पसंद आए, हमारे एफर्ट आपको पसंद आए तो इस वीडियो को लाइक कीजिए और हमारा कंटेंट अगर आपको अच्छा लग रहा है और अभी तक आपने हमारे चैनल को सब्सक्राइब नहीं किया है तो मेक श्योर टू सब्सक्राइब। सो विदाउट गेटिंग लेट, लेट्स गेट स्टार्टेड।
Hey, what's up guys? Greetings of the day to the viewers of this video and welcome back to ptscadexpert and myself architect Kumar Kapadia from the city of Surat in Gujarat. And for this course Revit BIM, which is the combo of architecture plus structure plus MEP for architectural segment. Today's session is going to be all about designing this single parametric family which has several other doors and windows parametric families nested and embedded within it. For example, you see that these are the sliding folding door shutters which has this operable horizontal and vertical louvers nested to it. It also has this center pivot door panel family which again has this horizontal louvers associated to it. This is the casement window and this awning window. Fine. So let me just acquaint you to this particular parametric family, wherein if I just select this particular family and if I just change this to type B, this is going to take a bit of time to regenerate. Just stay tuned. But what you will notice is that with this change in type, the entire configuration of that particular family changes, wherein you see that this sliding folding door shutter, the number of sliding folding door shutters decreases and the size also increases. This is because if I just go to edit type, then you see that it has all these parameters associated to it. The change in few numbers of which will give you a different result. So you guys just stay tuned and I will just change the few numbers and few parameters and you see that it will give a different result. And this sliding folding door feet to 17 feet and this to 2 and 1. And with this, if I just click apply, then what you notice is that the entire configuration of this particular window of this parametric family changes. But since it has been embedded with a lot of parametric formulas and families, it will take a bit of time to regenerate. So you guys just stay tuned. And what you notice is that we have a complete different configuration, wherein this sliding folding door shutter door shutter, the number of sliding folding door shutter decreases and the size increases, and we have a different configuration and different results. And also you see that this particular door family has changed its type from center pivot to off center pivot. Okay, this is because if I just go to this edit family, then this is the door template file where this particular family has been designed, wherein if I just take you to this exterior elevation, then what you will notice is that this particular family has been designed across this reference planes while constraining and assigning it several different parameters. If I just go to edit type, then you see that all these parameters has been assigned to this particular family, and all these parameters has this particular parametric computational formulas associated to it. And this is the reason that the change in numbers of this particular family in the project environment respond to that particular change. Okay, and you see that this is a different family which is reading horizontal lower module center rotation. This is again the vertical lower module align rotation. This is again horizontal lower align rotation. This is the casement window, and this is the awning window. All these particular families has been parametric families has been designed by me way back in 2016, and ever since till date I'm using this particular parametric formulas parametric families, doors and windows parametric families, from project to project with few alterations and few changes in dimensions. And once modeled, I can use it across several different files with the changes. For example, if you see that this is just one single this 4 to door 2D 3D double adjustable swing with horizontal louvers has 3 different types, wherein this is type A, which is aligned rotation, this is the center pivot, and this is the off center pivot. But all these doors are one and the same, but it has some or the other customization. And of this one family, that is the center pivot door family, has been used by me in this particular configuration. This is because if I just go to this particular family, if I just go to edit family, then again this is the door template file wherein this particular family has been designed, and several different types has been designed by assigning and constraining it with several parameters, and several different parametric families has been nested and embedded, wherein you see that this is that particular center pivot door family, wherein you see that this is the different family. When if you just go to edit type, edit family, then it will take you to that particular family file where that door panel has been designed. This is again nested with a different family. See, horizontal lower panel line based family. So you see that lot of families, one family within the another family. So this is that line based family, which again has this one nested family, that is horizontal lower single blade. And you see that only one family, when referenced and nested into another family, you can use from project to project. See, so all this has been made and which has been used by me from project to project with few alterations and few customization. So in today's exercise, I'm just going to show you that how can you create this particular configuration wherein you can have such sliding folding door panel shutters, and also this window panel shutters, casement and awning. Okay, and I'm going to show you that particular thing from scratch. So watch the entire video till the end. It is going to be very interesting and very informative session. And if you think that this video was worth, then kindly enroll for this course and let's learn together and let's grow together. So now, without wasting a single second, let's dive into the ocean of Revit, and I'm just going to show you this from scratch in a fresh new file. So from herein, I'll just open up this project environment of Revit, template, English Imperial, and default open and OK. So what we are going to do is that we are going to make that particular customization in a door template file. So essentially, to understand that, first I need to host a door, and you see that this is that particular door which I'm just going to edit. Okay, and it will open up this particular template file of that particular door template file where we are going to design that configuration. So if I just go to this ground floor, then what you see that this is the door template file where that particular door has been designed. Okay, so what I'm going to do is that we are not going to use this file, but we are going to use that door template file where this door has been designed. You see that it has this 3D component and this 2D annotation lines which are not visible in the project environment in 3D. Okay, and this frame elements, but I'm not happy with this particular thing. So what we are going to do is that we are just going to open up this template file. So file, new, and family, and you essentially need to have your library extracted properly. And from here, I will just open up this door template file and open. Fine. So this is that template file where we are going to design that particular thing. And I'm not happy with this frame that comes with Revit. So I'm just going to delete it. And herein, what I'm going to do is that I'm going to go to exceeded elevation. And yeah, what you see is that it has this inbuilt parameters, width and height and thickness. The three parameters which are the inbuilt project parameters associated to it, wherein I'm just going to stretch this and expand it a bit so we can have a larger configuration. And also I'm going to delete this lines which shows that indication that there is a door swing here. Fine, so this is the center reference plane, center left, right. Now what I'm going to do is that I'm first going to edit this width and change it to something drastic like 15 feet and height to something like 18 feet. Fine, 18 feet is too huge. I get that 12 feet is enough. Okay, fine. I just drag this parameter a bit far away. Okay. Now what I'm going to do is that I'm just going to edit this window frame, this window cut, opening cut, sorry. So opening cut, but before that, I'm just going to assign few reference planes, RP. RP is the shortcut for reference plane. And let me just, yeah, RP and okay, and I'm just going to assign that from original reference planes, from original this, but I cannot see the reference plane. Yeah, let me just drag this a bit. What I'm going to do is that I'm just going to make this opening cut 1 inch larger. Sorry. So just press tab until you read, watch this point, until you read opening cut and just edit the sketch. Okay, so you are editing the original sketch of that opening cut that comes with Revit. Fine, so I'm just going to drag it, remove constraint and lock it, remove constraint and lock it again, and remove constraint and lock it again. Okay, and with that I'm just going to finish, and herein I'm just going to assign parameters to this newly created reference plane. And from here, no, here it is not needed, only, yeah, this one, align, and yes. Okay, and I'm just going to select all of this and strike a parameter, and I'm going to use shared parameters text file for this. And I've already created one, but what you want, what you need to do is that when this dialog box pops up, just browse to a location where you want to save that particular file and say that create new. I'll just save this to desktop. I will call it yes, universal parameters. The reason of creating this particular shared parameter text file is that we are going to use a lot of parameters which will be common for this particular doors and windows family, which you can use again and again. Okay, so edit and this browse, and yes, universal text parameters, and from that I'm just going to create new, and I'm just going to call this door windows. Okay, fine, and new, and first is that rough opening gap, ROG for short. Okay, and fine, that parameter has been loaded, and just going to click OK. From the type properties dialog box, I'm just going to change that rough opening gap to 1 inch. Okay, and apply. The reason I'll just explain. Right now you won't understand, but the reason of doing this thing I'll just explain you. So first is that what we are going to do to this particular opening cut is that the first part is that for that particular door, what we need is to design a wooden frame. Okay, a wooden frame which we can snap to this particular opening cut. Okay, so again we are going to use a different template file for that, and new and family, and this time we're going to family types and English Imperial, and this time I'm just going to use a profile, yes, and a simple 2D profile. Fine, so this is the profile, and first is that what I'm going to do is that using the line command I'm just going to create something which looks like a typical door window frame. Okay, and the reason of creating that I would just explain you. So you have this one, two, three, the three vertical segments. So what I'll do is that I will create reference planes, one, two, and one, two, three, and four. There's a four, yeah, fine. And one, two, three, four, and five. Five horizontal and four vertical segments. So one, two, three, and four, and one more five. Okay. So now what I'm going to do is that I'm just going to create this particular profile across this reference planes. So line and one, two, three, four, and five, and six. Yes. And okay. So now with this created, what I'm doing is that I don't need this. So I will just delete it, that I just created that to have a reference of something. Now what I'm going to do is that I'm just going to use this line command and lock all these particular lines to this particular reference planes. Yes. And last one, lock, and this also lock. Okay. Now I'm just going to create a few parameters to this, wherein this, let me just scale down a bit. We can properly visualize it. Okay. Yes, and this to this. Okay, and all this dimensions. Yes. This I'm going to call shared parameters, edit, new, wall thickness. Okay, I'm going to add a couple of parameters associated with this typical door frame. So that is going to be wall thickness, and then throat depth, throat width. These are nothing but just the typical terminologies associated to a typical wooden frame. Then we have rabbet depth and rabbet width. Okay, and we have jam frame width, JWF for short, jam frame width. And what else? Yes, throat width, throat depth, wall thickness. Yes, and most important, thickness parameter. Okay, or let's say that door panel thickness. Door or window. So let's keep it generic. So let's keep it only thickness parameter. Okay, fine. And I'm just going to load all these parameters. And from that, first is that I'm just going to select what was the thing that I selected. Just click OK. Oh, this should equals wall thickness. Wall thickness. Okay, and both of this should equals throat depth. Yes, and okay, this should be throat width. Okay, this is the jam frame width. Okay, and Yes, jam frame width, fine. And this is the rabbit width. Okay, and this is the rabbit depth. Rabbit depth. And this is going to be just the thickness. Okay, so now this looks like a typical door frame which has been constrained with the parameters. Okay, and you see that when I flex this particular reference plane, the dimension flexes. Okay, so now I'm just going to change this numbers to the typical size, and right now you won't understand, but you'll understand once I load it into the project environment. So rabbit depth should be equal to 0.35. Rabbit width should be equal to, oh sorry, this should be equal to 0.75, that is 3/4 of an inch rabbit width, and rabbit depth should be equals 3 inches. Thickness should be equals 2.5 inches, which is the typical door frame. The thickness of the typical door frame which is going to take, this is going to be only 0.5 inches. Throat width is going to be 1 inches, and wall thickness, this is going to be 6 inches. Okay, and with this all changes, if I just click apply, then you see that this particular thing changes. Uh-oh. Oh, why is this creating a problem? Yeah, fine, okay. I guess that there is some problem for this jam frame width is 2 inch and throat width is, okay, throat depth is the problem. Yes, so throat depth should only be 0.5 inches and not 1.5. How did I? Yes, fine. So now this perfectly looks like a typical door frame. Okay, and what I'm going to do is that I'm just going to load this profile into what? Yes, this door template file. So this profile family 2 should go to family 1. Okay, and since it is a profile, so you cannot host, you can just host it, you cannot model it. So I'll just go to this family profiles, and you have that family 2. I'll just like to be specific, so I'll just rename it, calling it wooden frame. Copy and rename this and paste it. Okay, now what I'm going to do is that I'll just close this family 1, not family 1, this family 2, since I have loaded it into that particular door template file, so I don't need it anymore. But what I'm going to do is that now coming here, I'm just going to reference level and create and set work plane, and with work plane to be center front back, I'm just going to go to exterior elevation, and herein I'm just going to create a sweep and sketch path and pick lines. And what I'm going to do is that I'm just going to snap to the original reference plane of the original door cut. I'm just going to lock it 1 to 2 and this. Okay, and align. I'm just going to snap. Oh, sorry. Let me just join this to this. Okay, and align and just snap this point and lock. Align and snap this point and lock. And with that, I'm just going to finish and select profile and load that wooden profile and just finish. So that wooden frame is now hosted to that particular opening cut, but it will not be properly hosted. So since it is a profile, it has this instance parameter which you can edit. Wherein I'm just going to change this angle to 180 and this horizontal offset and vertical offset. So let's check that what horizontal offset corresponds to. 2 inch. Yeah, fine. So this is that particular fine. So this is the reason in that particular template file of giving this particular face the dimension jam frame width. Jam frame width refers to the door condition, the frame condition in jam, the position of this door frame in jam condition. That's why we call it jam frame width, and that's I have given it 2 inch because I know that in this project environment I'm just going to make this particular opening cut 1 inch larger. So with this 2 inch, I would exactly flush it and create that particular frame just like it is hugging a wall. Okay, so herein I'm just going to select this particular wooden frame, go to its type properties, and from herein I'm just going to pass on few parameters of this particular profile to this door template file, of which one is this going to be this jam frame width. And now we don't need to type every time, and this was the reason of creating that particular text file of that shared parameters in jam frame width, and you don't have to type every time. Okay, and what is that? Throat depth. Yes, throat depth is one which I'm going to pass. So it don't have that. So throat depth, yes. Okay, wall thickness, very important. Shared parameters and wall thickness. Okay. And throat width, I don't need, and thickness, yes. Thickness is, and it has already that inbuilt parameter thickness, so we don't need to change it. So this is how we pass on the parameters of this particular newly created the embedded file to this particular template file, or the one which you host, which is the host file on the family which you embed to another family. You have to pass on the parameters, and you see that now that it has all that parameters, that is jam frame width and this throat depth and everything. Okay, so with this I'm just going to select this particular profile and going to this jam frame horizontal offset. I'm just going to create this, make it equal to jam frame width. Okay, so whatever is the condition in the project environment, if you constrain it, if I would have just given it a variable here and not constrained it with a parameter, then you never know that what is going to be the the wall thickness, or what is going to be the this condition in the project environment. So in order to constrain it, if you constrain it with a parameter, then whatever is the situation or condition in the project environment, it will always stay in place. Now what we need to do is its vertical alignment, and from here if you just measure this, then this is 3.5. So you never know again that what is going to be the wall thickness. Right now it is how much? This is 6 inches. So in that case, this offset is 3.5. But what if the thickness of the wall is 8 inches or 9 inches in the project environment? And if you want this particular frame to expand accordingly. So in order to make this happen, what I'm going to do is that I'm just going to use some computation, wherein I'm just going to assign this a parameter and call it equal to wall thickness. Yes, wall thickness, and that is the parameter which has been passed on from that profile family also. Okay, and what I'm going to do is that I'm just going to make this wall thickness edit an instance and reporting parameter because I want to report it to whatever are the variables in the project environment. Okay, so with that, it is now a reporting parameter. And now what I'm going to do is that apply an OK, and for this I'm just vertical offset. I'm just going to define one more parameter, and that would be new and frame vertical offset. Okay, and okay, and frame vertical offset. Okay, now what would be that particular frame vertical offset? I would like to make that particular frame vertical offset an instance parameter, because I'm going to use on another instance and reporting parameter wall thickness as a formula. I want this particular parameter to be driven by another instance parameter, and that's why the reason I want this particular frame vertical offset to be instance parameter. Also, I'm going to use this particular throat depth. Throat depth is this. This is the throat depth. If you remember in the profiles section that we had designed, this is the throat depth. Let me just go to this particular wooden profile and just edit it. And you see that this is throat depth. Okay, so this is again has a relation with this wall thickness. That's why that also needs to be instance. Fine. So just frame vertical offset, and frame vertical offset should be instance, and also this throat depth should be instance. And what I'm going to do is that I'm just going to say that what should be the frame vertical offset. The frame vertical offset should be whatever is the wall thickness in the project environment. Okay, that minus Okay, that divided by 2, that will bring it halfway. Okay, and after bringing it, whether the wall thickness is 9 inch or 8 inch or 15 inch, it will divide it by 2, that will bring it halfway, and plus this particular throat depth. Okay, so in this case it's 3.5. Fine, so apply and okay. So now your frame is completely hugging that wall. Okay, and this was the reason of giving that particular parameter jam frame width, and this is the computation that we have made. Fine, with this now you have created the frame. Now we need to create the configuration, okay, wherein this particular family is going to have a lot of other embedded and nested families within. Fine, so I'm just going to draw a couple of reference planes. 1 to 2, 1 and 2, and 1 and 2, and also 1 over here. 1. Fine. All of that, I'm just going to strike a parameter. Mm. And yes, one more over here too. Okay, and what I'm going to do is that I'm just going to select all of these parameters and make it equal to new and transom frame width. Okay, okay, and transom frame width. Okay, and okay. And with that, I'll have that changed. What I'll do is that I'll just change the transom frame width to 2 inch. Okay, 2 inches. Fine. Now, what I'm going to do is that I'm going to define one more parameter over here. There are going to be a lot of parameters, so just 3 inch, yeah, 3 inch. This is better. Okay, and this should equals edit new and transom height. Okay, finish. The file already contains transom height. Yes, okay, I selected the wrong parameter. Fine, and I will just make this transom height to be 18 inches for now. You cannot change it from here, you have to change it from here. Yeah, where is transom height? Yes, change it to 19 inches. Apply, yeah, fine. So just see that parametrically expands. Now we have to snap that profile, that wooden profile, the door frame profile to this particular thing in order to achieve this particular configuration. You see that here there is a frame across this entire configuration. Okay, horizontal and vertical wooden frame. Fine, so let me just quickly do that. And with that work plane selected, set work plane, and yeah, center front back. What I'm going to do is that I'm going to create sweep, sketch path, and now for a couple of minutes I'm just going to follow the same process to create this particular profile. Just stay tuned. Align and lock. Align and lock. And sketch path, finish, select profile and wooden frame and finish. Now in order to pursue the placement of this, you need to draw one section and go to that section. Fine. So it is not properly hosted. This particular thing. So now guessing games, what we need to do is that 180, yes, and horizontal profiles is equals to jam frame width, yes, and vertical profile is equal to frame vertical offset. Yeah, so see, once designed, you can use those parameters again and again. And now this is perfectly corresponding to that vertical segment. See? Okay. Only thing I forgot for this is that the material part, and material and shared, select, edit, new, and wooden frame material. Okay. Oh, but that is the material parameter. So wooden frame material, and data type should be material. Okay, and use that. Okay, and okay. I hope the recording is on. Yeah, fine. So okay, and likewise just change this material also to this wooden frame material. Okay, now let's go to exterior and just hide this. Now I'll be pretty much quick and fast. So just stay tuned. Sketch path, pick lines, lock, align, dot and lock, dot and lock. Okay, and finish. Select profile, wooden profile, and finish. Section and guessing games again. Frame wooden material and 180, and profile is flipped, and vertical frame vertical offset, and horizontal should be equal to gem frame width. Okay, no, fine. So now we have to create, in order to make this in place, we have to create one more parameter, and that would be shared parameters. Select, edit, new, and negative gem frame width. Okay, and just use that negative gem frame width. Where is it? Okay, and fine, and just go to family types, and for negative gem frame width just type formula minus gem frame width. Okay, and that will become -2, and yeah, that is now perfectly flushed. Okay, see, what you need to just do is that join this to this, join this to this. Okay, let me just create other parts and pieces of this. I guess that this should have stopped here. So edit sweep and sketch path. Remove constraint and lock it. Yes, finish. And likewise for this also. Unjoin. Yes. Yes. And go to that exterior. Why is not visible? HR. Yeah, it was hidden. Edit sweep and sketch path. Certain things you won't understand right now, but once that thing is achieved and the modeling part is done, then you will understand and finish. Okay, now what I'm going to do is that I'm just going to create the vertical part of this. Sweep, sketch path, and lock, align, and lock, and finish, wooden frame, and fine, and HH. Let me just create another sketch path, pick lines, and this side align and lock and lock, and wooden frame, and just finish. And now let's see it in plan. Let's see it in plan, and yeah. So now we need to properly assign this in place. Vertical frame vertical offset. Yes, this is done. Yeah, so this corresponds to the configuration of that building profile. Fine. So this again, I click the wrong button. Okay, wooden frame material and guessing games 180. Profile is flipped. Frame vertical offset, and yeah, it's done. And join 1 to 2 3D, and yeah. Okay, so now you have this. Okay, the reason of stopping this here was that we were going to have this frame here. So join this and join this. Yeah. Join this to this. Yeah, everything is joined. Fine. Okay. Let me go to exterior, and now let me just quickly design this part. So create sweeps, sketch path, pick path, and align, dot and lock, and finish. Select profile, wooden profile, finish, and HH. Create one more sweep, sketch path, pick lines, inside, lock, align, bottom reference plane, dot and lock, this, dot and lock, modify and finish, select profile and wooden profile and finish. Okay, now let's go to plan again and properly position that in place, which is right now not positioned in place. So let me just select this and drag it and pin, and drag it a bit and then pin it again. Yes, select this, and again material to be equals the wooden frame material, and guessing games 180. Frame vertical offsets, and once created you can use it again and again, and this to be material to be wooden frame material, and 180, but the profile is flipped, I guess. Yes, and I'm right. And vertical frame offset is going to frame vertical offset. Okay, and just join them and watch it in 3D. Yes, it's perfectly created. Only thing is that you need to join that to this. Okay, the last part, this two, and for that let me just take this section here, and I don't want to see it, so let me just decrease this view range only till here. Okay, and create and quickly sweep, sketch path, and pick lines, lock, align, lock, and constraining reference planes to reference lines, wooden frame and finish, and let me do both of this also. Then once and for all, we will position all of them together in one place. Pick lines, lock, align, dot and lock, finish, wooden profile and finish. HH, create, sweep, sketch path, lock, align, and finish, wooden profile and finish. Yes, and now HR, and just go to that particular section where you have to position all this perfectly in place, and for that I will be pretty much fast. 180 and vertical frame offset, and horizontal is to be jam frame width. Yes, so that's not perfect. And with this, now this also wooden frame and 180 vertical frame offset will go to frame vertical offset, and yeah, that is positioned properly. This to be wooden frame material and 180, and profile is flipped, and frame vertical offset. Fine, and join all of that 1 to 2. Okay, and then let's go to 3D. And you have beautifully created that particular entire configuration. Okay, what you just need to do is that just cross check whether something is left to join. Yes, now everything is joined. Okay, now what we need to do is that we have to assign a couple of parameters here, wherein this would be the space for casement window, this would be awning window, and this would be lower's panel, or the, let me say that left panel, the align rotation, the pivot window, and this will be the sliding folding. Okay, so let me just from here to here, I would just call it a parameter and share parameter, select, edit. And now I'm just going to create a couple of parameters which we are going to use during the modeling process. So just stay tuned. So sliding, folding, width, all for short. Okay. Sliding, folding, panel space. Okay. New sliding, folding, door panel width. Sliding, folding, door panel height. Okay. And sliding folding width has been defined. Okay, fine. We will create all of that. We will create when we otherwise right now I cannot recall all of them. Step by step we will create all of them and keep on assigning. Fine. So this is going to be sliding folding width 8 foot 8 inches, and this is going to be right pane window, right pane dash window width. Okay, right pane, not panel. So just delete it. New and right pane window width, because we are going to reference awning and casement window, so that's why. New left pane door, let's call it pivot door. Okay, pivot door width. Fine. So okay and okay, and what we are going to select this for the right pane, right pane window width. Okay, fine. So now all this, what you see that all this particular things has been assigned, the parameters have been constrained. So for this last, we cannot assign a parameter, otherwise it will pop up an error that you're over constraining a sketch. So you have to use a parametric computation formula to assign this. Even if you just go and try to assign this a parameter, and let's just call it any random parameter, then you see that it will reference planes are over constrained. So what we have to do is that we have to use this particular width in order to assign the geometries that we design. In order to assign parameters to this part, we have to use the computational formulas. Okay, so I have already designed the parameter, that is left pane, or no, pivot door. I guess that's what it was. Pivot door, where it is, maybe not been loaded. Shared parameters, select and pivot. Yeah, pivot door width. So what would be that pivot door width? That would be equals overall width. Fine, we will use that particular computation when we come to that part. Okay. Right now, let me just design parts and pieces of this. Okay, fine. So for that, I'm just going to create one extrusion and set plane, and while going to reference level, we are going to host a glass onto this surface. Okay. Which surface we are going to use? Yeah, this surface. So I'm going to set and pick a plane and use this particular surface, and then go to exterior, and herein I'm just going to design one simple extrusion which I'm going to lock. Okay, lock all of this. Okay, and I'm just going to call this extrusion n is equal to shared parameters, and that would be one more parameter, that would be glass thickness. Okay, and okay, and glass thickness, okay. Yes, okay. And this is going to be equals glass material, which is the inbuilt material of Revit. So you don't need to design that material. You can just reference it. Fine. And this should extrusion end should equals glass thickness, which while going to this type properties dialog box, I will just select that glass thickness and change it to half inches, that is 12 mm, standard conventional door glass thickness, and just finish. Let's go to 3D, and yeah, see, your glass has been modeled perfectly in place, but I guess that it has been snapped. No, it is fine. We are actually seeing it from wrong side. Fine, so this is perfectly snapped. Okay. Now what we have to do is that the toughest part of this is that designing a sliding folding door. Okay, for that, what we again need to do is that just like we created that profile, we now need to create one generic model which we will use multiple times, even for this windows and even for uh, this particular pivot door. Okay, so what I'm going to do is that I'll just go to file and new and family, and this time I'm just going to use a simple English Imperial family templates and English Imperial and simple generic model. Okay, this template file I'm going to use, wherein I'm just going to design one door shutter. Okay, so I'll just go to this particular family categories and I'm going to tell Revit that whatever we are designing is a door. Okay, and as soon as you do that, you need to go to manage and object styles and change all these colors to black, otherwise it will reference those colors while modeling that, which I generally prefer to be black. And okay, and the last one. Okay, fine, apply and okay. Now what I'm going to do is that I'm going to create one door panel family. So I'm just going to create, and with that I'm just going to set work plane, and with work plane to be reference level, I'm just going to create RL. The shortcut is RL, create this reference lines. Snap it to the intersection of these two reference planes and draw it in the space. Fine. Just go to modify and align and lock. Locking is very important because we are going to snap a 3D geometry onto this reference planes. Reference line, and we are going to snap a 3D geometry onto this reference lines. So reference lines in Revit are nothing, but those are just the lines with integrated work plane associated to that. For example, if I just go to create and set and pick a plane, you see that 1, I press tab, then 2, I come here, then 3. These are the integrated work planes associated to this particular reference lines, and those lines are very powerful lines onto which you can snap a 3D geometry. Okay, so one more time, create and reference line, snap to the intersection of this, draw this, modify, lock and lock. Okay, now I'm just going to draw one reference plane here, and I'm just going to measure it, and all this make it equal to width. Since we have told Revit that whatever we are designing is a door, it has automatically preloaded this particular 5 parameters associated to the door. Okay, so from this we can change this to width. If this was just a generic model file, then those parameters wouldn't have appeared. Okay, now this it equals width. Now this also I will just change this particular. When you select this line, you see that temporary dimension that pops up. I'll just select this particular thing and change it into a permanent dimension, which also again I will change to width. Okay, now I'm just going to assign a rotation parameter to this, wherein I'm just going to select this and call this shared parameter edit and that would be equal to 3D door panel swing. Because it is a 3D element, so that's why 3D door panel. Okay, 3D door panel swing. Oh, but again, I forgot to change it into an angle parameter. 3D door panel swing. And data type should be, it is angle parameter. So, okay, and fine, and okay. And I'm going to make an instance since I want to change it instantly when I load it into the project environment. And I would generally like to group it under constraints. There is no logic, you can group it under any category, but angle parameters I would generally like to group it under constraint. Okay, and with that, this you see that you have created an angle parameter, and if I just test it out, then you see that this reference line rotates with this angle parameter. Okay, and also if I just change this width to 5 feet, then you see that this reference line expands. Okay, testing out of parameters at each stage is very important. Now I'm just going to make this 0, and I'm going to design a door panel, but I'm going to design it in the elevation. So I'm just going to say that create an extrusion, and I'm going to set plane and pick a plane, and I'm just going to select the integrated work plane. I just showed you that the reference lines has that integrated horizontal vertical reference planes to it. From that, I'm going to select this vertical ones, and I'm just going to go to front elevation. Okay, and here too I would have actually first design a reference plane over here and just hide this reference level and assign this a parameter align, and yes, and this should equals height. Okay, now let me just go to reference level. Again, same process, create and set work plane, or let's say the extrusion, create extrusion, modify extrusion, set work plane, pick a plane, and pick this plane and go to front. Fine, and just create and draw a rectangle and lock all of that. Fine, now we need to create the inscribe frame first. Fine, the inscribe frame which will be hosted to the wooden frame, and the inscribe frame which will be having the actual door panel. So that inscribe frame would have the thickness of, let's say, offset and negative 1.5 and rectangle, and I'll just draw that particular rectangle minus 1.5 inch, and I'll just draw that. And now before finishing off, I will just constrain it with the parameters. If we want to change this in the project environment, then we can change it 1 2 3 4, and I just call it share, select, edit, new, and that would be inscribe frame thickness. Okay, and just finish it, and from here I will just change this to inscribe frame thickness. Okay, and fine. Okay, so and the thickness should equals to extrusion start 0 and extrusion end should be equal to thickness. Fine, and it should be equal to a typical door thickness, typical door panel door panel thickness, that is 2.5 inches. Fine, apply and okay, and just finish. Okay, now let's go to 3D. Not 3D of this, but this. So now you see that this particular inscribe frame has been created. Okay, if I just go to then testing of parameter, and you see that entire 3D geometry rotates because we have snapped it, we have created it with that, with reference, we have created that with the with that reference lines, with the work plane of this reference lines. You see, when you select this particular thing, it reads that the work plane is the reference line. And since that reference line rotates, the entire 3D geometry also rotates. And I just change to 5 feet. You see that the 3D geometry also expands. Okay. Now we need to create the another parts and pieces of this. So for that, what I'm going to do is that create, set plane, pick a plane, and again create that shape. Watch this point. Again press tab until it reads that reference lines, and again go to front. Okay, but what I'm going to do is that this time we are going to design the door panel, which will be having a style and rail door panel within it, which will be having a piece of glass. So what I'm going to do is that extrusion and rectangle, and I'm just going to 1, 2, 3, and 4. Okay, and this time for rectangle, I'm just going to use an offset of -3 inches, and I'm just going to create this. Okay, and just like we created the parameters for that inscribe frame, I'm just going to create a couple of parameters for this door panel, the style and rail door, which wherein this is going to be frame. The only reason of creating this as a parameter, I'll show you once loaded in the project environment. Frame bottom height, then new frame top height. Okay, new, I'm just going to call it style width. Okay, and from that I'm just going to use the frame bottom height. I would have loaded that frame top height and style width also. Okay, so now we can use that frame bottom height. Yes, okay, yes, this to be frame shared parameters and frame top height. Yes, and this, the vertical elements of the door are called the style, and the horizontal elements are called rail. Fine, so you can also name this rail top height and rail bottom height, but I have named it frame bottom. Fine, that's okay. And select this and share parameters and call it style width. Okay, style width, and okay. Fine. Now the computation I'm going to use this time is going to be slightly different, wherein you see that right now the reference plane which we have used is this, and we are hosting that geometry with respect to that reference plane. But I want this particular thing, irrespective of this inscribed frame thickness, I want this to remain always. Sorry. I want this particular door panel to always remain in center. So what would be that computation which I'm going to use? So that would be, and I'm going to strike a couple of parameters, wherein I'm just going to call this new shared edit and call it frame. What would be it? Glass offset exterior frame offset exterior. Yes, frame offset interior. Okay, and one more, door panel thickness. Okay, and I'm just going to load all of this, from which I'm going to select one by one. Frame offset exterior, new frame offset interior. Okay, and one more, the glass door panel thickness. Okay, now what would be that computation? So I'm going to use this particular door panel thickness as a parameter which could be used for the computation of referencing this 3D geometry. And I'm not going to assign this door panel thickness parameter to any of the 3D element, but I'm just going to use it for computation. Wherein I'm just going to call this door panel thickness equal to 1.5 inch. So now what would be the frame offset exterior? So the frame offset exterior would be whatever is the overall thickness, thickness of this inscribed frame, this thickness, divided by 2 plus the door, minus door panel thickness you need to be very specific while typing. Revit is very case sensitive. So thickness minus door panel thickness. So whatever is the thickness, that divided by door panel thickness, open and close parentheses, divided by 2. So that will change this frame offset exterior to half inches. And what would be the frame offset interior? This should actually be not frame but door panel exterior. Sorry. Just edit and delete both of this. Frame offset exterior delete, because you cannot edit it. Just define 2 more. Door panel exterior, I would like to be specific. Door panel interior. Okay, and load both of this, and this should be equal to door panel exterior. Okay, fine. So that has now changed, but I would just like to cut and get rid of this too. Delete and delete. Okay, and what would be, add one more parameter, that was the one that we created, door panel interior. Fine. So what would be the door panel exterior? That would be the thickness minus door panel thickness divided by 2, that is half inches. And door panel thickness interior would be door panel exterior plus the door panel thickness itself. So that will be 2 inches. So whatever is the door panel thickness, I mean whatever is the overall thickness in this project environment, this will exactly stay in center. See, if I just apply this, okay, and if I just change this extrusion start to door panel exterior and this to be door panel interior and just finish, then what you see that this particular door panel is exactly in center of this inscribed frame. Fine. See. Yes. See. Okay. So this should be equals material part and shared parameter and inscribe frame material. We don't have that. Edit, new, and inscribe frame material. Change it to material. Okay. One more, door panel material. Change it to material as well. Okay, and both of them, inscribe frame material and door panel material. Load that both. From that, select first inscribe frame material. Okay, and that would be instance. So I can change it instances for what many instances of that door place I can change that instantly for every instance. Okay, now this is going to be the new and shared, and we have already created that door panel material. Okay, fine. So now this file has this 2 parameters, door panel material and door frame inscribed frame material, of which this door panel material needs to be instance, and this 3D door panel swing angle. Apply and okay. Now what we need to do next is, again, while going to reference level, let's say that front elevation, we need to design the piece of glass. Okay, so again we are going to use that same computation, so it would be a quick revision for this particular thing. When I'm just going to pick a plane, sorry, not pick a plane, set work plane, and work plane should be reference line. See, it's highlight. Fine, the vertical plane of that reference line. Fine, and from that I'm just going to create an extrusion, and this I'm going to snap here. 1, 2, 3, and 4, and this would equals material of glass, that is the pre-existing material of Revit, but extrusion start and extrusion end. So again I'm just going to load 2 more parameters, shared parameters, and that would be edit and new and glass offset exterior and glass offset interior. Okay, and glass thickness, I guess the glass thickness is already there. Fine, so we don't need to design it. Okay, and both of this, and from that I will just select this. Okay, glass offset exterior, and one more, shared parameters, glass offset interior. Okay, and the glass thickness. Yes, glass thickness. Again, I'm just going to use that same computation wherein I'm just going to apply this glass thickness 0.5 inches. And what would be this glass offset exterior? That would be the door panel exterior, whatever it is, plus the glass thickness. And what would be the glass offset interior? That would be glass offset exterior plus the glass thickness. This is a bit confusing, but it is just a computational formula, nothing else. So 1 and 1.5. Okay, fine, apply and okay. And with that, if I just finish it, what you notice that this has placed in center, but its width didn't increase. Door panel exterior plus glass thickness. Okay, glass thickness is 0.5. 1 and 1.5. Yeah, so what is the issue? Apply and okay. Oh yeah, fine. We made the computation, but we didn't assign the for. Yeah, fine. So this extrusion start should be glass offset exterior, and extrusion end should be glass offset interior. So you see this inscribed frame. This is the inscribed frame, which is having the door panel, and this door panel is having a piece of glass. And irrespective of this thickness, these two guys will always remain in center. And to show you, I just change this particular thickness to something drastic like 6 inches. And with that, if I just apply, then what you notice, because of this computational formulas that we have used, this door panel and this piece of glass always stays in center. Only thing is that we need to test out the angle parameter with this change in variables. 45, wow, no issues. 90, 135, 180, that is completely open up the door. Okay, and you are never going to go beyond this, but 270 is the hardest angle. So you need to check that. And while coming to that, I'll just increase this width to 45 and everything expands perfectly and no issues. And again, I'll change this to 45 and width to 3 foot. And we are going to have a 3070 door. And this thickness to back to 2.5. Okay, and this angle to 0. Just what we need to check is the height parameter. Yes, height also expands. So I'm just going to call it a 3070 door. Fine. Now what I'm going to do is that I'm just going to use this particular one family several different times. The hardest part is done. Now what we need to do is that I have to use this in this particular door template file several different times, but with some or the other customization. Okay, so first is that what I will do is that I will just load this family into the door template file, and you see that you can place it, but I will just press escape and I will just delete this particular file because it's loaded in this template file and don't need it anymore. But if I just plus drop down this arrow, then you have this family 3, of which I will just rename, and I will call this sliding folding door panel, and just copy it and rename and save it. Okay, now before hosting this to this particular configuration, I would just like to create particular few parameters for that particular sliding folding panel. For that particular sliding folding door panel, I would just like to create few reference plane and I would like to do some computation. Fine, so just try to follow. So what I will do is that I want 3 shutters on this side and 3 shutters on this side. So I will just create a couple of reference plane, 1, 2 and 3, and 1, 2 and 3 over here. Okay. I am just going to measure it 1 to 2 to 3 and 4. No, 1 to 2, 3, and just let me scale down this. Yes. And also I'm just going to create 1 to 2 to 3. Yeah, fine. I should have created it once at a go. So delete and 1 to 2, 3 and 4. Okay. Now, what I'm going to do is that I'm just going to load that sliding folding parameters which I had already created, but I need to load them in order to assign them here. So I'm just going to add new parameter, shared parameter, and from that I'm just going to use this sliding folding door width is already created. Sliding folding width has been assigned. Now I need to create 1, 2 and 3. So first is that I will door panel width. Fine. Sliding folding door panel width, and I'll just take this all the way up and sliding folding door panel width and door panel height. Sliding folding door panel height. Okay. One more. Sliding folding door panel space. And okay. Where did it create? Yeah. Yes, and sliding folding door width and sliding folding door height. Where has it been loaded? Not been loaded. Sliding folding door height, and yes, okay, fine. I'll just apply this. Okay, now what I'm going to do is that I'm just going to create 2 number parameters, integer parameters. That is, this would be family parameter. I don't need to create a shared parameter of that because I'm going to use this only for this file. Left panel, and that would be integer. And I'm going to group it under constraints, not construction, constraints. Okay, and one more, that is going to be right panel and integer, and group it under constraints. Okay, now I'm going to say that right panel should be 3 and left panel should be 3. So what would be this sliding folding door panel width? That would be the overall sliding folding width divided by, in open parentheses, left panel plus left panel plus right panel, and close. Okay, so that would make its width equals 1.5. Okay, now what would be this sliding folding panel space? Okay, actually it was correct, guys, but there was one thing which I forgot, that once this particular sliding folding door panel which we designed in a generic model and we embedded it, but we forgot to pass on the parameters of this. So in order to compute this, I need to pass on the parameters of this particular thing. Okay, so what I'm just going to do is that I'll just going to click apply. Okay, and the sliding folding door panel, I'll just drag and drop. Okay, so herein you see that it has this instance parameters and type parameters which we need to pass on to this particular template file. So I'll just select this particular door panel 3D door panel swing angle, new, shared, and you see that I already designed that. 3D sliding folding door panel swing angle. Fine. And instance and constraint. Okay. And okay. Fine. Next is that I need to say that this should equal the door panel material and this is equal to inscribed frame material. Fine. Now, before transferring the width and height parameter from this, I should check that whether the width and the height parameter has been computed in it. The sliding folding door panel width is fine. That sliding folding overall width here. This is the overall width. This is the overall width divided by the left panel and the right panel. So the overall width, sliding folding width divided by left panel plus right panel. So that will be the sliding folding panel width for one individual panel. Okay. What would be the panel space? That will decide on the basis of this angle of rotation. But before that, what would be this sliding folding door panel height? So that would be this overall height divided by this transom frame width minus transom height. That will decide this particular height of this particular sliding folding panel. Okay, so I will just go to here and say that this height would be overall height minus transom height minus transom frame width. Okay, so 10.3. Yeah, fine, perfect. Apply and okay. So you see that this would be 10.3, but we cannot directly assign it as a parameter. We have to compute it this way, because if I just go and try to assign this the parameter, then as I said, it would over constrain the sketch. See, and that would labeling this dimension would over constrain the sketch. So we have to create that computation in order to use this particular configuration. Okay. So from here in now, I will just, this angle parameter has been passed on. I need to pass on this 3 parameter, that is thickness should be equals thickness. This width should equals sliding folding door panel width, and height should equal sliding folding door panel height. 10.3. Perfect. Apply and okay. Okay. So now this is perfect. Only thing is that now we need to go to reference level. Yeah, fine. This is perfect. So now what we need to do is that we need to design this space, this panel space. We need to compute this. Okay. So what would be that panel space? So that is again one computational formula, and it is just try to follow that this panel space should be sliding folding door panel width times cos this particular thing 3D sliding folding door swing angle plus thickness times sine the same 3D sliding folding swing angle. Copy and paste and close parentheses. Okay, so that will design the panel space, which will be exactly equal to this door panel width, and apply. And instance parameters cannot be used in type parameters. Panel space is driven by instance parameter swing angle. Okay, so this panel space again needs to be an instance parameter. Okay, apply and okay. Fine. So with this, you see that this panel space are exactly equal to this width. Fine. Only thing is that if I just change this to 45, what you see that this computation changes. This also the angle changes and this space also changes. So now we need to host it. But before that, I would just like to go to 3D, and you see that the width of this particular panel is too less. So what I'm going to do is that here, if you remember that in its host file, we have given this also the parameter, the style width. Okay, and that was the purpose of giving this, so we can compute it. So you see that style width I can change to 1 inch, or let's say 1.5 inch. Okay, and the frame bottom and top from frame bottom height and top height, that also I can change to 1.5 and 1.5. Okay, apply and OK. So that will change it here, and now you can load that into the project, family, and apply. So you see that changes. Okay, now what we need to do is that snap it here. So I'll just go to align this, and you see this reference planes associated to the 3D element, which we can snap, and this top to this. Okay, now what we need to do is that mirror, that is DM. I guess that I need to copy this first. Okay, and then DM, yes, and align, lock, and lock. Okay, again copy, same process, lock, and lock. Okay, now we need the exact mirror of this over here. So what we can do is that select all of this, DM, and from center I will just check this copy and paste it, but we need to snap it, we need to lock it, sorry. So just select this, lock, uh, reference planes, and this, no, yeah, we need to lock it here. Okay, fine, 1 and 2, and likewise lock this here, and 1 and 2. Okay, now let's go it in 3D. Yeah, fine, see, perfect. Now if I just go to this particular 3D, and if I just change this to 0, you see that will flush. Okay, and if I just completely open it, then it will completely open. Okay, and it will completely close, then it will completely close. Fine. And if you want this width to exceed, then what you need to do is that you need to go to the type properties and change its width from 15 feet to 18 feet, and sliding folding width to, let's say that, 12 feet. Okay, and apply. So with this, you see that the panels expand automatically. Okay, and with this, if I just change this to 45, okay, you can also assign it a visibility parameter, wherein you can design a different type, wherein you can have only one panel on this left pane and 2 panels on right pane, or 2 panels on left pane and 3 panels on right pane. But you see that this is taking a lot of time. So in order to learn all that, you need to be conceptually clear, and you need to enroll for this course. Then only I'll be able to teach you that in detail. But for now, let's proceed ahead with the modeling part of this and finish this. Okay, so I will just finish this. Okay, and now we are going to use this particular family. This is family 1. This is sliding folding door panel. All of them are sliding folding door panel. Yeah, fine. So I'm just going to use this particular family and convert it into another door. So you just watch how do I do that. So edit, and herein I'm not going to do anything, but I'm just going to make a save as of this family, and I just call this lowers, sorry, not lowers, left panel door. Okay, left panel door, fine. And after renaming it, I'll just load this into the project again, family again. And now this is the different family. What you need to do is that I will just go to reference level and I will again associate this parameters, this 3D door panel swing angle that should equals. This time I'm going to use that same 3D panel door panel swing angle. Okay, instance and constraints. Okay, door panel material into door panel material and inscribed frame material is equal to inscribed frame material. And type parameter now very important. This time we are going to assign this thickness to same this thickness, but this width to a different parameter, that is left door left panel. I guess that door right panel, right pane window width and left pane door width. I haven't designed that. Door width left. See, this is the right pane window width. It should have left pane. Okay, or maybe lowers panel. No, pivot door. Yeah, pivot door. It was pivot door width. Yeah, fine. Pivot door width, and just click OK. It already contains. So pivot door width. Yeah, fine. But I need to first create that computation. Yes. So where is that pivot door width? Yeah, it's already loaded. But what would be that pivot door width? That would be this overall width minus this window, left pane window. What is the parameter that has been assigned to it? See, right pane window width, overall width minus right pane window width minus sliding folding width. That would decide this width. Okay, so let me just go to this and pivot door width, that should be equals overall width minus right pane window width minus sliding folding width minus transom frame width times 2. Okay, right pane window width. Okay, copy and let me just edit this. Select this one is creating a problem. So right panel window width, edit, right pane, delete it, new right pane, or let's just call it window width. Right pane window, or let's just call it window width. Window width, yes, fine. Okay, and where is it? Window width. Yeah, so just drag it. Yes, pivot door width. What would be pivot door width? That is overall width minus just this window width. Yes, so that will decide the pivot door width. Okay, apply, and pivot door height would be equals to overall height, I guess. Yeah, fine, apply and okay. So I would just create this and say that left pane door width should be equals to window width and height should equals the overall height. Apply and OK. And with that, now if I just change this to 45, apply and OK, align, lock, and align, select this and snap and lock. Okay, let's go to 3D. Fine. For this, as I've shown here, you can also have a center pivot rotation and off center pivot rotation, but all that is very much time consuming. I'm just here to explain you the concept of that. Okay, now this same family, we are going to convert it into the casement window and awning window, and that would be really very easy. So what I'm going to do is that first is that I'm just going to create a couple of parameters wherein the width wouldn't be a problem, but there would be two parameters, that is height. So new, and this would be casement window height, and this would be awning window height. Okay, casement window and awning window. Casement window height and shed and awning window height. Okay, casement window height would be overall height minus transom frame width times 2. Oh no, casement window height we will assign a parameter. Awning window height will be the computation. So herein I'm just going to go to, and from here, from this reference plane to this, yes, I would say this equals casement window height. Okay, and for awning window height, we will create a computation that would be overall height minus transom frame width times 2 minus casement window height. You need to be very particular while typing, very case sensitive. See, this one parameter I didn't type properly, so it is width. Yes. Transom frame width. Okay. Yes. Casement window. Casement window height. Yes, and that would be the awning window height. Okay, so I would just say that this would be 6 foot and 5 foot 8 inches. So let's keep it 5 foot 10 inches. So both of them will be equal. Apply and OK. Fine. And now with this, I'm just going to select this particular thing and go to edit family. And first tell Revit that this is not a door, but this is a window. Fine. And with that, all the parameters remain the same, but only thing that when you load this into the family, then it will read this as not as a door but as a window. So I will just load it, and you don't need to resave. I guess that sorry, you need to make a save as of this and family and call this casement window. Casement window. Yes, and then load it into the project. Okay, and you can place it here, but just need to pass on. So again, this 3D door panel swing angle. So one more parameter and couple of parameters, casement C window swing angle. and that should be equal to angle. Okay. C, one more, new, A, awning window, swing angle, and yes, all of that, both of them. And from that, I will just select this C, casement window swing angle, instance, and group it under constraints. Okay, fine. And door, I forgot to let me just go to this family types again, and this door panel material should, oh yeah, but we can just change it there itself. Yes, so this door panel material should equals shared, select, edit, new, windows panel material, and that should be equal to material category. Okay, windows panel material and windows panel material. Okay, instance and group it. Yeah, since it is a material, so group it under material section only, material and finishes. Okay, windows panel material should equals windows panel material, and inscribe frame material should equals inscribe frame material. And for type properties, now thickness should equals thickness, width should equals casement window width, or not casement window width, just window width. Yes, and height should equals casement window height. Apply and OK. And let me just change this casement window swing angle to 45. Apply and OK. And you see that this pivot, rotation pivot is here. So we just need to DM and uncheck copy. And yeah. And then align 1 to 2. And this to this. And yeah. Okay. And just need to give it a offset. And what would be that offset? That should be transom frame width. Yes, 2 inch. Okay. 3D. And yeah, see. So now if I just close this window, that will properly occupy the space. Fine. Perfect. So this is that window. You can manipulate the height and width from here, wherein this, if I want this 4 feet, apply and OK. Fine. So this will be smaller and the awning window will be bigger. Now the challenge is to create the awning window. Okay. From this particular file. So I will just select this particular thing and go to edit family. And this is the casement window. So I will just make a save as of this again, family and awning window. But what I'm going to do is that I'm just going to use a slightly different method in order to model this particular window, wherein I am just going to delete all of this, because the window that we are going to design is not in plan, but since an awning window, what is an awning window? Awning window is a window which has the rotation in height, I mean in plan, not in plan, but in section, rotation in section. So we have to design that in a different work plane. So I don't know why that's like that, but whatever you design here in right elevation will perfectly appear in the 3D environment in another file when you embed this particular file. So in order to design this particular thing, I'll just go to not left elevation, right elevation, and herein I will design that particular panel. Okay, so what I'm just going to do is that this I'm going to equals height Where is height? Yes, height 4 feet. Reference planes are over constrained. I didn't assign any of the parameter. Front elevation. Oh yeah, front elevation already has that. So just delete it. Right, and this should be equals height. Okay. Now, if you remember, then we created for that particular casement window, we created that reference line which we logged to this two reference plane, but we did that in plan. But now since we want the rotation in section, what we will do is that we will design that particular window here in right elevation where we will create the reference line not in plan but in elevation. Okay, left right elevation. So I will just snap to the intersection of this two reference plane and just click align, and I'm just going to follow the same methodology. Okay, and angular dimension, and this should be equals shared parameter then awning swing angle. Yeah, awning window swing angle. Fine. It is not an angle parameter. uh, Delete, and awning window swing angle, and just change this to angle. One step you forget, and a lot of problems. Awning window swing angle and instance and constraints. Okay, and this I'm just going to change this temporary dimension to permanent dimension, but this time I'm not going to make this equal to height, but what I'm going to do is that I'm going to make it equals this time I'm not going to make this equal width, but this time I'm going to make this equal to height since we are designing this in elevation. Okay, now this rotation angle, if I just change to 90, then it will flush here. And what I'll do is that I will just create a reference plane and set plane and pick a plane, and this time I'm just going to select this plane and go to front elevation. Okay, and herein I'm just going to assign one parameter, and that would equals to width. Okay, and I'm just going to follow the same steps now. It will be very easy and I will be very fast. 1 2 3 4, and this to 0, and this to thickness, and this to inscribe frame material rectangle, and minus 1.5, and this would be a quick revision of that particular door family that we designed, which we used multiple times for that sliding folding panel also, and for door panel also, and for casement window also. And inscribe frame, yes, and with that, fine, I'll just finish. And now I'll quickly create two more extrusions, wherein this would be 1 2 3 4, and since we have already created those parameters, door panel exterior, you can just yeah, right now let me just door panel exterior and door panel interior, and material is equal to door panel material. Okay, fine, and with that, rectangle and minus 3 inch. Okay, and this is going to be frame top width, bottom height, frame top height, and this is going to be style width. Okay, and just finish. The only change you need to do is that you need to convert this door panel exterior, shared, edit, new, window panel exterior, and we would have done that for the casement window also, but I forgot. Anyways, window panel interior, and one more Windows panel. Windows panel material is already defined, so you just need to add that. Fine. And this to WP exterior. Where is W? Yes. And this would equals WP interior. And this would equals window panel thickness. Window panel thickness is not there. So window panel thickness. This is absolutely very important step, because when you try to schedule and this particular thing, then if not this parameters are not changed, then you cannot have the perfect documentation of that. And this door panel material should be equals window panel material. Yeah, okay, fine. So with this, okay, this 3D door panel swing angle should equals, but awning swing angle is already defined, so just delete this. We don't need this particular parameter in this file. Apply and okay, and then create two more extrusions. One lock it, and this would equals glass offset exterior, and this would equal glass offset interior, and this would equals pre-existing material of Revit class. Fine. With this, now if you just go to right elevation, then what you notice that you see that this particular inscribed frame is having this window panel, which is having this glass, and all the computations are perfect. If you just change this 45, then it will perfectly rotate. If you just also change this height to 5 feet, see this panel also expand, and this also, and everything is parametric. Okay. So now I will load this particular awning window into this file. So project and family 1, and yes, and I will just place it somewhere. Before proceeding, I would just like to go to this particular casement window, and the things which we forgot, for example, this door panel material should equals window panel material. Perfection is very important. Just remove, we should have just edited that. Yeah, edit, and that should change to Windows panel material. Door panel exterior should equals window panel exterior, and door panel interior should equals window panel interior. And okay, and is there anything left? Door panel thickness should equals window panel thickness. This is the purpose of creating the text file, shared parameters. Okay, and with this I'll just load this back into the project and just overwrite existing version. And this window has two windows, casement window and awning window. Fine. Awning window I will just close it, and casement window also I will close it. Both of them are loaded in this. Fine. Now very important is that how will you align this? For that again you need a section, and I would like to take this section here, Okay, and first is that I will just take this section, and this is that particular awning window. We cannot properly visualize it because of the view range, and I will just expand this view range till here. And now, yes, we can completely visualize it. I will just align this and align this to this. Oh, align this to this. Yes, and lock. Okay. Now, very important, first pass on the parameters that this awning swing angle should be equals. We have already there in shared file instance and group it under constraints. Okay, fine. And material inscribed frame material is equal to inscribed frame material, and window panel material is equal to window panel material. Fine. And edit type, and most important is that uh, thickness should go to thickness, width should go to door width, I mean window width, window width, yes, and height should equals awning window height, which we have already computed and designed that parameter. And okay, so you see that this awning window height, something is missing. Overall height minus transient frame width, yes, minus one parameter, transient height, yes, and that marked it perfectly. But what is very important, that where will you snap it? Okay, so for that I would just again like to go to exterior, and let me just, yeah, until we can see only this particular thing. Okay, and now align and tangent frame width times 3, height minus tangent frame width times 3, apply and okay. Yes. So now first is that I will just go to awning window swing angle and change it to 45, so we can snap to the reference planes. Yes, remove constraints, and because we snapped it to this reference plane and locked it, so that's why it was actually we were supposed to lock it here, and align, and yes, lock it, and this exterior and lock it. Okay, and go to exterior again, and here in HL, and align this and snap this to this and lock it. Okay, fine. And now we don't have any issues, and you see that our family is complete. Okay, let's just check test this out. Testing is very important before loading it into the project environment. What I will do is that I will just change this casement window height to something like 5 feet. Okay, and apply. So you see that everything expands parametrically. Okay, and let me just change this 3D swing sliding folding is fine, but this to 90, apply. Yeah, fine. Okay, now we need to design a sunshade, which is the visibility parameter. For that, I need to go to exterior again, and I would just draw a reference plane HL 1 and 2 and RP and 3 reference planes. Okay, what would be this? This would be 1 and 2, and this would be, yes, this would be shared parameter, or let me just create a family parameter, sunshade depth, and this would be sunshade extension. Okay, I would just change the sunshade extension to sunshade extension. Where is it? Yes, sunshade extension to 15 inches, or let's say 18 inches, and sunshade depth is equal to 8 inch, and apply and OK. Oh, sunshade depth is equal to 6 inches, I guess. Let's find 8 inches. Okay, fine. Now we are again going to create a profile. We are going to snap a profile onto this. So I'll again go to this file, new, and let me just go to that wooden profile. Profiles and wooden profiles and edit. I'm just going to delete all of this and RP file and save as family sunshade profile. Okay, this is going to be sunshade depth. See, if you have created that shared parameter, then here we would have used that using that shared parameters file, but we created the family parameter, so we have to type it, and this should be sunshade width. Okay, and this would be 15 inches. Oh no, 15 inches would be too much. 12 inches, and this depth is 8 inches. Okay, and herein I would just create lines, lock, these are just the 2D lines, lock, and 6 inch and lock. Okay, and LI connect 6 inch should be too much, I guess. Okay, that's fine. Create lines. Yes, and TR. And this is locked to this, and this is locked to this. Okay. Okay, fine. And I'll just load the sunshade profile in family one. And herein I will create one sweep and sketch path, pick lines, lock, and lock, and just finish. Oh, but we forgot to select the work plane. So we need to go to the reference level, and the work plane, very important, should be the face of the wall. So pick the work plane, and this should be the work plane, and then go to exterior, and now sweep, sketch path, pick lines, lock, and align, and lock, and lock, and finish. And now we have that sunshade profile, which you can just reference. Only thing is that we need to go to section to properly position it. ZA. Yes, so it is not properly snapped. Maybe its work plane is edit, pick a plane. Yes. So we need to play around with this parameters. So 90. Yes. And profile is flipped. And DM with copy and check. This is a bit confusing. Finish. And 180, 270. Oh, yes, perfect. And then the vertical offset, you can also 18. No, this is not the vertical, so horizontals. 18. Negative. Yes, and it's perfect. Okay. Now what you can do is that you can just apply a material and sunshade material instance. Okay, fine. And also give it a visibility parameter. Yes, and that would be show sunshade. And make it a type parameter and group it under instance, or make it an instance parameter, group it under others. Fine. So sunshade. Fine. With all this changes, now is the time to load this particular parametric door into the project environment. So family 1, I'll just load and I will just snap it and no, and I'll go to 3D of this CC, R enter. Okay, and herein under doors you will have, since we had edited that door template, you will have that file under doors and family 1, and you can just rename it sliding folding doors. Copy and just rename it and paste. Okay, with this, now if you just select this, you see that you have all this editable parameters which you can edit instantly also, and you can define a different type also, and you can do everything. For example, if I just change this particular 3D sliding folding swing angle to 0, the door will shut, and this to 0 as well, and casement and awning window to 0 as well, and you can see the configuration. And here there is some problem, I guess. Might be during the modeling of this particular awning window, we might have snapped to some wrong level, and that's why the wrong line, and that's why it is popping up that error. Yes, okay, but that's fine. 0 is not compatible. Yeah, okay, fine. 0 is not a parameter for awning window. There is no issue with that. There is no error. That's perfectly fine. The only thing is that when you design an awning window, you cannot exactly give it a 0 degree angle. Fine. You can give it 2 degree. See, so that will perfectly expand, but you cannot give it 0. So this to be 90 and this should be 0. And everything shuts. Okay. And you can give this different materials. Right now, I will just give it the same material to all of that. Control V and Control V. Yes. And there might be a problem for passing on of the parameters. That's why, see, this inscribe frame material has not been converted to instance, and that's why it is not appearing. But yeah, fine. The only thing is that I have forgotten. Let me just rectify that error. Edit, and all of this parameters should be instance. Yeah, okay. This and wooden frame also instance. Okay, apply and okay. Yes, apply and okay, and then load it back into the project. wherein we can instantly edit the material parameters also. Fine. Now what you can do is that here I guess that sunshade material should be concrete. RCC. Concrete. Yes. Cast in place gray. Fine. Okay. With this, now you can define a different type. Go to edit type and duplicate and sliding folding over door 2, or we can just edit it within here also, wherein you see that width, I'm just going to change it to 21 foot, transom height to 3 foot, and overall height to 18 foot, and casement window height to 7 foot. Okay, and yes, fine. With this, apply, and okay, perfect. The only thing is that there might be some problem. I might have forgot to assign this width. No, width is perfectly assigned, window width. But that window width has to be a computation. Window width. Yes, see. So that should be overall width minus transom frame width times 2 minus sliding folding width. Window width sliding folding door width width minus transom frame width times 2. Yeah, fine. So where am I changing? No, not the window width. Oh, cancel. This is the door width. Oh, that didn't expand. So where is the pivot door width? Width minus window width minus sliding folding window. Yeah, this is perfect. So why is that creating a problem in the project environment? Why didn't it expand? Window width nahi. Oh, sorry. This should equals pivot door width. Yeah, one change, one mistake you make, and you see that Revit is very strict. Fine. Now, if you just change this particular parameters again to that, wherein the width should be 25 feet and transom height should be 3 feet, and window width to be, let's say, 4 feet. Automatically everything will update. 2 feet, let's say that 3 foot. Okay, and height to be 15 feet, and this to be 6 foot. Okay, and just apply and fingers crossed. Yes, perfect. We don't have any errors. Okay, fine. And with this, if you want the sliding folding width to be 15 feet or let's say 14 feet, then that is also, panels will automatically expand and adjust accordingly. Okay, and now we can open up this door. Okay, fine. So you see that how time consuming and difficult it was. So if you want to conceptually get clear regarding all these concepts, then enroll for this particular course and let's grow together and let's learn together. Fine. Bye and have a nice day.